This is one of the intro activities that we do as we start our functions unit, is create a story to go along with the graph below. Not a lot of information. Think about what the graph in red looks like. Maybe you might want to assign some labels to the axes and just tell a story. We'll come back to it. Here we're going to look at interpreting graphs. So I want you to think about what happens to the height of an ice cube when it's placed in a refrigerator. What happens to the height of an ice cube when it's placed in a hot oven? What about when it's placed in a freezer? You can jot a couple phrases down that you think would happen to the height. We're going to make note of some of the adverbs that we're using. So now here we have 5 graphs and we have 5 statements. The sentences below describe the motion of 5 cars on a highway. Match each sentence with the graphs below. So the first one, we have the car's speed remains constant. Car number 2, the car's speed increases slowly but steadily. Number 3, the car's speed increases sharply. Car 4, the car's speed decreases gradually. And number 5, the car's speed decreases suddenly. So go ahead and take a minute to fill in the blanks and see which car matches each graph. How did you do? You can take a look at the car numbers down at the bottom. Car number 1, the car speed remains constant. You can see it is just a flat line here. It's not moving at all. It's not going up or down, it's just going straight. And if you were to think about time, and you could think about speed, and over time, the speed is just staying the same. We're going to be looking at words like slowly, steadily, sharply, suddenly. Those will kind of give you a clue as to what's happening with the graphs. If you look at the difference between A and D, you can see that you've got one graph is steeper than the other, and that's going to affect what's actually happening in the graph with the description. So this is going back to the story graph that we had in the beginning. So one of the things you might want to do is identify labels. So you'll see I have identified time, and then the Y is the water level. So this is a situation that could be interpreted from this graph. So you have over time the water level does the following. It increases steadily, which is going here to here. It remains constant, the level is unchanged, and then it decreases sharply. And so you'll notice that you have a change here and a change here. You've got a starting point and you have an ending. So you have something happening here, which is one situation. This is your second situation. This is your third situation. So if you go ahead and take a look at your possible situation, a special bucket is filled with Gatorade. So there's your time, and this again is your water level. So the bucket is being filled, and it sits a while on the sidelines, and then the players dump the Gatorade on the coach, which means you have your water level or your Gatorade level has just dropped. So when you analyze graphs, break it into segments where you see the changes or turning points. You're going to think of your keywords: increases, remains constant, drops, and then you've got your adverbs. So you can think about this graph here and what would be happening in this situation. So you can go ahead and jot something down for this. This lesson is talking about functions and relations. A set of ordered pairs is called a relation. Ordered pairs are not always going to be XY coordinates. For example, you can earn points by coming in first, second, third, or fourth place in a track meet. And you can make these facts a relation by creating ordered pairs. First place earns 5 points, second place earns 3 points, third place earns 2 points, and fourth place earns 1 point. So here we're going to finish this relation. So we have an ordered pair of 1, 5, 2, 3, then it would be 3, 2, and 4, 1. And the information is coming from up here. There are many ways to show these relations. You can use a table, which is here. This is called a mapping diagram, and that's a graph. So you can see with the track scoring, you have 1, 5, 2, 3, 3, 2, and 4, 1. Over here, this would be your mapping diagram. So fill this in, and this is how you would show the relation by drawing these lines connecting the ordered pairs. And then over here, you would have 1, 2, 3, 4. Oops, I don't have leave myself enough space. So first place would get 5 points. Second place would get 3 points. Third place would get 2 points, and fourth place would get 1 point. Why did I include the 4 in here? Because when you make a graph, you have to have evenly spaced intervals. So that's why the 4 is there. But you'll notice there's nothing marked off on it. And then on page 239, you'll see number 3, 5, and 6 that you can work on those if you want. And page 239 is coming up in the next couple pages. So now we want to remember that ordered pairs are XY. X values are also known as, so X values are also known as the domain, the input, and the independent variable. Your Y values are also known as the range, the output, and the dependent variable. I have a new stylus, so this isn't working very well. The domain of the track scoring is 1, 2, 3, 4, and the range is 5, 3, 2, 1. Now here's where we're getting into functions. Okay, functions are special types of relations. Functions pair exactly one X value with exactly one Y value. Therefore, one domain is paired with one range. Do the values in the table below create a function? So sometimes these mapping diagrams can be kind of hard to look at, so I'm actually going to write them out. And I'm going to say, okay, this is 75 is getting paired with 2, and 68 is getting paired with 2, and 25 is getting paired with 3. So is this a function? Yes, because the X value does not repeat at all. Okay, so now the next example, do the order pairs below. So you have 7, -7, 9, -1, 7, -1, 12, 0, 15, 0. So you got a 7 that shows up twice. So this is no. The X values, this is your big hint. Is there more than one? Does the X value repeat? Good quote from the book, I decide whether a list of ordered pairs is a function by looking at the X values. If they're all different, then it's a function. When listing the domains and the ranges, only write the values once, even if they repeat. It's customary to write the numbers in order, but it's not required. So take a look at this example. So the domain is 7, 9, 12, and 15. You see, we don't write that 7 twice, even though it's there. We don't write it twice. And the range is -7, -1, 0. we don't write the -1 and the 0 twice. So on the next page, you'll see page 239. You can work on 7 through 9, 11 through 13, and then the page after that has page 241, numbers 33 and 34. You can ignore this right under this page. These are the 2 pages that you have in your notebook that I gave you. And you can do the work right on this sheet if you want, or on some of the scrap paper. This last page talks about the vertical line test. The vertical line test can be used to visually determine whether a graph relation is a function. So if you look at the tables here, so table 1, if you go ahead and if you look at the your x values, you'll see none of those repeat. And so this is going to be a function. If you look at the values here on table 2, you'll notice that the 1 repeats. So this is not going to be a function. If you look at the 3 examples down below, if you were to pick a point on the circle, so I'm going to say, all right, I'm going to pick this point right here. If you draw a line through that point vertically, will it hit another point on the circle? And it does. So this is not a function because you'll see that it has 2 x values that repeat. Over in the second one, wherever you draw a vertical line, it's not going to hit another point on that parabola. So this is a function. But here, if you go ahead and pick, looks like 3, 2 right here. If you go down, you're going to hit 3, -2. There's going to be lots of points on this. So this is not a function as well. So when you see a graph, vertical line test just means pick a point, draw a line straight up and down. If it hits another point on the graph, it's not a function.